Hello friends, today we will discuss some important points of C# programming. So here is the list. First one is what is linear data structure in C#, what is stack in C#, what is queue in C#, along with the difference between stack and queue in C#. So let's begin. So here is the first topic, that is a linear data structure. A linear data structure stores elements in a sequential straight line order where each element is connected to one before and after it except first and last. So linear data structure is a thing like where we store the elements in a sequence. In a sequence, data is stored from first to last, and it is also connected with each other. So it is if we are storing in indexing like 0, 1, 2, then it is storing in that format. It is easily accessible. So here are some features of linear data structure. First one is elements are arranged one after another. You can traverse the data from start to end in a single pass. Examples are stack and queue. So features are like I already told you, elements which are arranged in a sequence format in a proper structure like one after another. So that sequence followed by linear data structure. And if we want to access the elements from start to end, so we can do that in linear data structure. So here are the examples of linear data structure, that is stack and queue. We will see one by one with examples. So our first linear data structure is stack. A stack is a linear data structure that follows the LIFO approach, last in first out principle. The last element added to the stack is the first one to be removed. So here we have the stack, which is a linear data structure that follows the LIFO approach, means last in first out. Suppose we have 3 elements 10, 20 and 30, and we can access the last value added like 30, we can access it first like last in first out. So this is the main concept of stack, means if we want to remove that we have to remove the last element in first. So it is like follow the top approach. Here are some methods of stack like push method, pop method, peek and count. If we want to add some elements to the stack, we can use push method. If we want to remove some items from the list, then we can use a pop method. And if we want to display the values which is in the top value, we can see with the peek method. And if we want to check the elements, total elements in stack, we can check it with count. Here we have example of stack. We are using string. So this is a generic concept, we will discuss it in later videos. Here we are pushing the data, means adding the data to stack, and if we want to display, we are using peek. Here pop we are using to remove the element from the top, and count we are using if we want to count the elements in a stack. So here we have a real world scenario, undo functionality in text editor. Every action is pushed onto the stack. When the user presses undo, the last action is popped and reverse. So here is one real world scenario. Suppose if we are working in a Word document, and we write some text over there, and we want to change that text. So we change that text easily. And suppose on some specific point we want to reverse that code, or we want to undo the changes, then we can undo that changes and the code is reversed. Then text is reversed, means the latest value is removed and the previous code will reflect. Now we can see this one example in Visual Studio. Here we have stack example, stack with string values is equal to new stack string. Okay, and now we want to add some data, string data, then we can use push method for that. Okay, now suppose if we want to display the data, then we can use peek method for that. Display values, then here we can use values dot peak method. Okay, now let's see the result of this one. Here it is displaying the last value added to stack, that is C#, means it is following the approach of last in first out, means whatever we added in last means the current value, then it displays it on top. Now if we want to remove the top element, then we can use pop method. For that, it will remove the top value from stack. After that we have to see the remaining value. Values, then we can see it with peak. Now let's see the removed value from top. So first it is displaying the top value that was added last, means C#. Now it removed the C# from top value, means the last value which is accessible, so it removed it from the list. Now after that the top value is developers in a stack, because it is removed. Now we have two values and the last value we have to access first, so developers is the top value. Next if we want to check the count of the elements, then we can use count. Total values in that. Suppose if we want to see all values, then we can use for each loop. Here we can iterate the values in a sequence. It will display all values after removing one value from the top. Here we can see the total elements. Okay, now let's see the total elements. Here we have total count. So after removing one element from stack, then remaining is 2. And after that we applied for each loop to iterate all values or display all values in a sequence. So it is displaying first developers, which is in top, and then programmers. So if we want to display all values in a sequence, then we can use for each loop. So this is the main thing in a stack. If we want to add the data in stack, then we can use push method to add, and if we want to display the data, then we can use a peek. On top value it will display, and if we want to remove the top value, then we can use a pop method. And after that, if we want to count the values in stack, then we can use count. And next, if we want to display all elements in a sequence, then we can use for each loop. Next linear data structure is a queue. A queue is a linear data structure that follows the FIFO approach, first in first out principle. The first element added is the first one to be removed. So queue is a linear data structure which follows the approach of FIFO, means first in first out. Whatever list or whatever the first value we added to that list, it is first accessible. So this is the main thing in queue, first in first out. Or if we want to remove that first element which is added in a front value, then we can use queue. Here we have some methods. If we want to add the data, like push the data into the queue, then we can use enqueue method. And if we want to remove or remove the element from the queue, then we can use dequeue method, which it will first remove the front value. And peek method is like if we want to display the front value, then we can do it with peek method. And if we want to count the elements in the queue, then we can use with count. So queue is totally different with stack. Stack is following the approach of last in first out, but queue is following the approach of first in first out. Next we have example of queue. Here we are using queue with the string. With enqueue we are pushing the data into the list. With the peek method we are displaying the front value. With the dequeue we are removing the front value from the list. And if we want to count the total elements in the list, we have to use count. So here we have one real world scenario, customer service call center. Each customer is added to the queue and they are served in order they arrived. Here we have one example of call center. Suppose two customers visited that call center, and which customer came first, then its queries will be first resolved on the priority. So this is the main approach of queue. Now let's see the example of queue. Okay, queue. Here we can use integer. Some numbers we will add here. Okay, then if we want to push some data in that queue, then we can use enqueue for adding the data or pushing the data into integer format. Here we have some values. Okay, now suppose if we want to display this data, means whatever the list is, but which value we added first, then it is first accessible, means first in first out approach. So this display front value, that is first accessible. So we can use here peek method to display the front value. And suppose if we want to remove that front element from the list, then we can use dequeue method for this one. And after that we can again see the new front value, that will be 45. Here we can remove front value, and here we can see the remaining front value. So let's see what will be the output of this one. Here first it is accessing the first element, that is first added to the list, means that is 111. So it is in front of the queue. And after that we removed the first element, means the front value, that is 111. And after removing the first element from front, then the second value is on the front, in front queue. So that is 45. After that if we want to check the count, then we can do it with count. Okay, total front count. Okay, and let's if we want to see all elements in a sequence, then we can use for each loop. Right line, all elements one by one in a sequence it will display. Now let's see this one. Here we have 3 counts after removing 111 from the list, from the front value. So the remaining count is 3, 45, 77, 33, 44. After that we applied a for each loop, like to display all elements, all remaining elements in the list. Then we applied for each loop, and we have the elements in front value we have 45, then after it 77, then 33, 44. So this is the concept of a queue. First, if we want to add data, then we have to use an enqueue method, and if we want to display the front value, then it will display you the front value with the peek method. And if we want to remove the front value, then we can achieve it by dequeue method. After that, if we want to check the total number of counts, then we can check it with the count. And if suppose we want to display all elements in a sequence, then we can follow for each loop. Next we have difference between stack and queue. So what is the main difference in between these two linear data structure? First we have order, means the stack is following the order like a LIFO, last in first out, means last element added, then it is first accessible. And in queue it is following the approach of FIFO, means first in first out. Add operation we have, if we want to add data in stack, then we have a push method, and in queue we have enqueue method to add the data in the list. Remove operation, if we want to remove some data or some element from that list, then we can use pop method. And in queue we have dequeue method to remove the front element. Next we have the peek element, like if we want to display the current element, means in the top, means the last in first out, means the last value added, it is on the top, then we can easily display that element, that value. And in queue, whatever we added first, then it is first accessible in the front queue. Use cases are undo, redo, backtracking and reversing strings or data. And in queue we have task scheduling, queuing jobs. Stack we have, if we want put some data into the notepad and we want to reverse that text, then we can apply the undo, redo operations. Then it is a kind of example of stack. And in queue, whatever we have, suppose we have some orders in a queue, like a queue order 1 2 3 like that, and whatever order we placed first, then it is first accessible in queue. Direction 1 and top, whatever we have a value on the top, means last in first out, last value added we means it is on the top and it is first accessible. And in queue we have to and front and rear, whatever we added value for the first time, then it is first accessible, so it is in the main queue, means front queue. Next we have the summary. So let's revise what we learned today. First one is linear data structure, to add data or elements in a sequence order. If we want to add data or access the data in a sequence, then we have a linear data structure. Its examples are stack and queue. Stack is following the approach of LIFO, means last in first out, means whatever we value added value in the last, it is first accessible, means we have 10 20 30, then the last value, that is 30, which is first accessible, in that is in the top. A stack follows last in first out order, the last element added is the first one is removed, commonly used for undo actions, back navigations. And a queue is following the approach of FIFO, means first in first out, means whatever we added in the list first, then it is first accessible. Suppose we have the string like programmers, developer, CSharp, then the value added the first, that is a programmer, so that is first accessible. And if we want to remove that from the front, then we can remove programmers, then the developers will be the front value. A queue works in a first out order, the first item added is the first one removed. It's used in scheduling print queues. Difference between stack and queue. Stack removes the most recent item. In stack, I already told you the recent item which we added in the list, that is first accessible, and first if we want to remove that, then the last element is removed from the list, that is on the top. Queue removes the oldest, means whatever value we added first, then it is first accessible, and if we want to remove that, then the first value will be removed from the list. Stack uses push pop. Stack uses, if we want to add data in the stack, then we can use push method, and if we want to remove that data, we have a pop method. While in queue we have enqueue and dequeue method. Enqueue is if we want to add data, then we can use enqueue method, and if we want to remove that data from the list, then we have a dequeue method. Stack is best for reversing or backtracking. So stack is best if we want to reverse the data or perform some undo operations on some text, then it is best for that. And queue is idle for order based processing. As I already told you, suppose if we have some orders in a queue, order 1, 2, 3, then the order 1 is on the front, so it is first accessible in queue. So queue is the best approach in that scenario. So these are today's topics. You can revise all these topics in your Visual Studio. If you have any query regarding this, you can mention them in the comment section. So let's wind up today's session. Thanks. See you in the next video.